The world's population reached 8 billion people in 2023, which means that the average population density of the world is about 52 people per square kilometer. However, this number varies widely across different countries and regions, but one thing is for sure, population density can change over time depending on factors such as population growth, migration, urbanization, and development. And as people move and shift, it can also affect the quality of life and happiness in different areas. Some studies have found that higher population density can be associated with higher levels of stress, noise pollution, crime, and even infectious disease transmissions, while others also point about higher levels of social interaction, cultural diversity, innovation, and public services. So mapping population density is very important because it can help us understand how people are distributed across different regions and how that affects various aspects of their lives, such as access to resources, services, infrastructural health, environment, and culture. So in today's tutorial, we'll be using some of the 3 common methods, which are Choropleth maps, SMIPE maps, and contour maps, to create some powerful analysis of population density in R. Hello folks, this is Milos. Welcome back to my channel as I take you on another exciting data visualization journey with R. This time I'm going to show you 3 easy ways to map population density with ggplot2. In specific, we'll be using WorldPop data, and then we'll be creating first of all the Choropleth map, second the spike map, and finally the contour map. Our first task is to install and then load the packages that we need. So we're going to go ahead and define here a list of libraries that we need. The first one is the umbrella package tidyverse, from which we'll be using ggplot2 for data visualization. The second one is the Terra package, which we'll use to load and then modify the raster file, which in this case is going to be gridded population density on a world scale. The second one is gsco-r, which we will use to load the national boundaries, and based on that we can then crop the area that we need. The second is the SF package, which we will use to create the bounding box of our country, and then using that bounding box we can go and use ggmap and get one of the terrain layers, which is going to serve as a nice background. Finally, last but not least, we'll be using the ray shader package to also create 3D population density maps. Now that we have the list of libraries that we need, the next thing is to check if these libraries are already installed in our system. So what I'm going to do here is I'm going to use this list called libs, and then I'm going to go ahead and enter the row names of installed .packages. Now, if they're not installed, so if any of these so-called install libs equals false, well, in that case, what we need to do is we need to here open curly brackets and we need to tell R to install packages. But we don't need all the packages here. What we need here is we need those libs that are in the list of libs that are not among the installed libs. And finally, once we do this, we simply need to also load these packages that we installed. So for that, we can use this lapply function, which is applied actually to the lists, since we have the list of libraries, of course. So we're going to apply this to the libs. We're going to apply the function library, which loads, and only for those characters of those libraries. Our main source on population density in today's tutorial comes from the WorldPop organization, which is an interdisciplinary applied research group with a focus on improving the spatial demographic evidence base and the use of data for health and development applications, which is based also at the University of Southampton in the UK and works with governments and UN agencies and also donors, and has so far produced over 45,000 data sets on different things, one of them being mapping population. WorldPop population density data is a type of geospatial data that estimates the population, the number of people actually per square kilometer in different regions of the world, and then it produces a grid which is 1 by 1 in raster format. So we can easily access this one by simply here adding a data and then in front of this worldpop.org, which is actually going to take us to their main repo. Over here we can click on the first folder, which is called GIS. And then we're interested in population. So we're going to click here on population. And here you have actually a bunch of options which might be in the beginning quite confusing. So what we actually need here is this global 2021-2022 1 kilometer UN adjusted. So this is what I was telling you about, 1 kilometer grid, so 1 square kilometer grid in a raster format. But this one is adjusted by UN numbers. So they have estimates and then they compare it against the actual UN numbers of population. So we're gonna go for this one and click on this folder, which is gonna expand things. But then things get also a bit confusing because you get 2 folders here, which is called constrained and unconstrained. Basically what you have here, constrained is you will get raster grid files only for those areas that have population, and unconstrained also takes into account areas that are not populated. So basically it fills out the area of the country itself. We'll be opting for the unconstrained one. So you can open it here. And then of course there are 2 possibilities, 2021 and 2022. And we're gonna go for that one. Once you're here, what you will notice is a lot of folders with only 3 letters. Each of these folders stands for a country, where these 3 letters are ISO 3 codes. So in this case, you need to know your ISO 3 codes in order to be able to access this. And in this tutorial, we'll be doing the population density map of the Netherlands using these 3 different methods. So the ISO 3 code for the Netherlands is NLD. So we scroll down and we find here NLD. So we click on this, and here is the link actually to our file. The good thing is that it's not constrained in terms of how you can access. There is no API. And also the second good thing is that it's not zipped. So this is basically simply a TIFF file that you can download to your local drive. So you can do it manually, or you can actually just copy the link here, copy the link address. And the next thing is that we will use this link to load this data directly into R and then work with it. In the next step, I'm just gonna paste here that URL that we previously fetched from the website. And I wanna actually bring your attention to one piece of the part here of this URL, and that is that this is actually a pretty generic URL that you can modify and use for any other country easily. So what you only need to do here is replace this NLD and then also NLD with the ISO 3 codes for the country that you need, because this is the ISO 3 code for the Netherlands, and this is what is distinguishing this URL. But if you want for any other country, you can check out this link, and this will lead you to a GitHub repo with the table of all the ISO 3 codes for all the countries. Going back here, we will define this as our URL, and then we're going to wrap it up into these double quotation marks. And once we do that, we can actually load this. That's right, we don't need to download, we can directly load. And for that purpose, we can use Terra. So we're going to go ahead and define our object. So population data, which is 1 square kilometer. And then we can use simply Terra here, Rust, and then we can just pass this URL to it. And this will solve the thing. So after you do this, and if you run then Terra plots, and then you plot actually this, you should be able to see a map, gridded map of population density for the Netherlands that looks something like this. In order to work with ggplots2, we need to turn this raster file into a data frame where each actually cell will be converted into the centroids of that cell. So it's going to have X and Y components, which are going to be the coordinates. And finally, it's going to have a third column in this data frame, which is going to be the value. In this case, it's going to be the population density value. So let's go ahead and create this. We're going to call it population_df. We're going to pass to this population data 1 km. And then we can use as data frame function, and here we just simply need to say that X and Y equals true, meaning I want this to return X and Y coordinates. All right, so if you run quickly this and then just inspect the first few rows, what we should get is the following. I'm just gonna increase this so that you can see. So we have here X, we have Y, which are the coordinates, and then we have this third column, which actually inherited the name of the layer that we loaded. So we want to actually replace this third one with something like, let's say, pop. So we can use here names of this population DF, and we want to change only the third. So we're going to put here 3, and let's call it, for example, just POP. Before we jump into ggplot2, I would like to here define a theme that we're going to be using in all of our plots, and I also want to define the color palette that we'll be using. So let's start off by defining a function gloriously known as theme for the win, where we will actually define exactly the theme that we want to use. So I'm going to start off first with defining a theme minimal. Theme minimal is the one that basically removes most of the things, but it does keep some, so which we also need to remove. And to do that, we can use that theme here. In the theme one, we can define other things. So one of the things that we can do is we can remove access line. And in order to remove from ggplot2 anything, you can use here element blank. So that means that we can also remove some other things. One of them is, for example, access.title.x. So for the x axis, we can remove the title name, and we can do the same for the y-axis. So I'm just going to copy this and paste here. We can also remove the axis text, and we can do that for the both axes. So I'm just going to replace here title with text. Once we do that, we can go ahead and also a bit customize the legend. So in this tutorial, what I'm going to do is I'm going to position the legend at the top. So I'm going to say here that the legend position equals top. And then I'm also going to further customize the legend title, which in this case it's a text. So you need to tell ggplot2 that it's a text by providing this argument called element text. And within this one, you can then specify the size. So for example, I can go for 8 pixels here. I can also change the color. It can be, for example, charcoal gray. The same thing I did for the title, which actually can be here 9. We can also go ahead and define here for the text. One thing I would also like to do for the title, by the way, is to define a bit its position. I would like it to be closer a bit to the legend itself, just to save the space. I'm going to say here that the vertical justification is -1, so it's moving to the south. And I would like it to be horizontally justified, so I'm going to say here that h_just equals 0.5. All right, we can go back here. As we said, legend text can be, let's say, 8 pixels. We can also specify some other things. As I said, in the background, if you're using theme minimal, which we're using, you also need to get rid of some grids. And one of them is panel.grid.major. So this is the major one. Simply what we can do is to emit element blank. Element blank. So once you do for the major, you can also remove here for the minor. So you can just put here minor. And one thing that you can also do for the plot background, you can basically just do a white background, which actually solves most of your problems. So what you can do here is you can do plot background, and then plot background is element rect, so rectangle. And here you can say that you want to fill it with white color, and you don't want actually to color those edges, so you can just leave it, the color as missing. And finally, what we can also do is we can also readjust the margins here using plot margin. Plot margin works with units, and here we need to pass a list of 4 things. So for each side of the plot, the top side is going to be equal 0. It means we're not going to shrink it, we're not going to expand it either. Right hand side also we're going to keep it at 0. Bottom side also 0, and finally the left hand side also it's going to be 0. Here you can also specify then the units that you're going to use. Let's say, for example, lines. Very convenient thing about R is that you can access a lot of different palettes for your purposes, and one of them is called hcl.colors. And you can check out this image in search of your favorite palette that you can use, and this is also the code that you can use. In this specific tutorial, we're going to be creating an object called pulse. It's going to be based on HCL colors, and from this one we're going to be using Viridis, and we're going to be using 5 values of Viridis. So, but we're not going to be constrained to this. We can actually expand this palette by creating palette, and we can expand it to even more. And for that purpose, we can use color ramp palettes function from R, and pass here cols, and then pass the number of new values that we want to create based on this. So I go ahead and put, like, let's say 512 here. First method is making a Choropleth map, which is basically cells that are colored in a certain way depending on the population density value. The advantage of these maps is that you can easily spot what is the size of a certain area based on the color. In this case, the lighter the color, the higher the population density, and reverse, the darker the color, the lower it is. The problem is, of course, if you're colorblind and if colors are not colorblind friendly, in our case they are, but if they're not, then you will have the problem understanding what's going on. So there might not be the best ones if you choose the colors that are not colorblind friendly. So let's build our map and let's call it P1. Here we're going to be, first of all, calling ggplot2, and then we're going to define our one and only layer using Raster here. Raster, the data is going to be the population df that we just created, and then Raster has actually three mandatory fields, three aesthetics fields that are going to change based on the values from this population df. The first one is the x coordinates, the second one is the y coordinates, and the third one is the fill. So this is how we are going to color those cells, and this one is going to be based on the third pop column. So we defined our main layer, and then we can go ahead and customize things, and one of them is, for example, that we want to customize the colors that we have. So for that purpose, we can use scale here gradient, and the reason why I'm using this one is that we have a continuous scale. So this makes sure that we actually pass continuous also color scale. One thing that you can define here is your legend title, and you can use argument name for that. So we can, for example, say people per one, and then if you want to add square kilometer, you need to go outside of these quotation marks and then specify km at 2, which is going to create exactly what we need. So people per 1 square kilometer. The next thing is the colors that we're going to use. We created that pal object, which extrapolated colors. And then finally, we can also remove any NA values if they're there using this n.value equals NA. One also things that we can customize is the appearance of the legend, and for that we can use guides. So in the guides, our main aesthetic is fill. So we are building legend on top of that. So we need to specify here fill equals 2. And then because we want to create a continuous or legend based on continuous values, we're going to use here guides color bar. Within guide color bar, you can specify several things. One thing that I want to do is I want to specify that my legend is going to be horizontal. So once I put that legend is horizontal, I can also change its width and height. So for the width, you can use bar width here, and I can make it a bit longer using this 12. And also I can make it a bit thin. So for that, I can use bar height. And bar height can be, for example, 0.25 or something like that. And then finally, I can also decide where my title is going to be, and I'm going to position my title at the top. So I'm going to say here, title position equals top. And then the final one is simply adding the theme for the wind that we previously created. And once you do this, run everything and print this P1 object, you should be able to see the population density map of the Netherlands based on this first method, which is the Choropleth map. Which allows you to see, these different colors, where the light colors show higher population density and darker colors show lower population density. And there's also at the top this nice color bar legend with also bins that show you where the things are. If Choropleth maps are not working for you for any reason, including color, then spike maps might be the way to show population density, because they create actually bumps based on the population density value. So the higher the value, the bigger the bump on the map it is. So in this tutorial, we'll be using this first ggplot object that we created, and then we're going to pass it to Ray Shader, and then we're going to create this interesting spike population density map. The first thing is that we want to do is grab the width and the height of the raster, because then we can then use that to plot our map in a specific dimensions. So we're going to first of all grab width, and we're going to name it W here. So width is actually the number of columns from that population data 1 kilometer, and the height is the number of rows, so n row. All right, and once we actually run this, we can quickly inspect, okay, what are the dimensions in pixels of this raster? So they're going to be quite small. So the width is going to be 470 and height is going to be 336 pixels. Okay, so that's good to know, because the next step is to create our scene using Ray Shader. So if you never use Ray Shader to create scenes with ggplot objects, you can check out one of my previous tutorials where I explain in depth how you can do that. In this particular tutorial, we'll be using plot.gg function and then passing the ggplot object that we previously used. So that's going to be p1. And then we can go ahead and specify width and the height of our scene. So for the width and height, here we need to use inches. In inches, you want to actually make sure that your width and height are below 10 inches. So that's not then a very, very huge screen. So what you can use here is width, and you remember it's 470, that's the value. So what you can divide it by 50. And if you do that, if you divide it by 50, you can get something like 9.4 inches, which I think is pretty decent. And then for the height, you can also do the same thing. Just make sure that if you are dividing here by a certain number your width, you should also do it for height so that you don't distort your image in the end. The same way you define this, you can also define the size of the window of the scene, and that one is regulated by window size. Here you can pass either 2 values or you can pass 1 value. So what you can do here is, again, you can go and, let's say, for example, use width and height. They are quite small, but I think it doesn't really matter because this is just like a window size. Next thing is, what is going to be the height of your spikes? And this one is managed by the scale arguments. The default scale value is 150. It doesn't tell you much until you actually see in practice what it looks like, but we're going to go on and exaggerate this value. So instead of going for 150, we're going to exaggerate. We're going to go for 750 and see what we get there. The second thing is that I want to minimize the solid plane around the map. So I'm just going to put here solid equals false. I would like to have the lights in the scene. So I'm going to put here that shadows equal true. Now the shadow intensity is something that actually manages how strong your shadow is going to be, but it's not very intuitive because the value of 0 is the strongest possible shadow and 0, 1 is basically non-existent. I want to completely remove shadows here because this is not the point of this map. So I'm just going to put the value of 1. Then you can also specify what is going to be the angle of the lights. And here I'm going to go for 225 degrees, which is southwest. You usually go for this one. The default one is 350, which is more like northwest. You can also specify what is going to be the angle of your map. And for that, you can use the phi argument. Because I want it to be more like flat, I'm going to choose something which is closer to 90 degrees. So I'm going to go here for, let's say, 85 degrees. You can also choose to what extent your map is going to be tilted. And for that, you can use the theta argument. So if I choose here 0, it means it's not going to be tilted. You can choose a positive and negative theta values depending on to what side you want to tilt it to. And finally, you can also create zoom here. Zoom and maximum zoom in is the value of 0. The maximum zoom out is the value of 1. I'm going to go ahead for something which is like 0.55. And once you actually run this, you should be able to see a new window opening up with a scene that looks something like this. So if you follow all the steps, you should be getting that. And once you have the scene, if you are happy with the scene, you can go ahead and start rendering. If you're not, however, happy with the scene, that can also be readjusted. There are 3 things that you, for example, can readjust. So you can use here a ray shader, and then you can call a render camera. So render camera allows you to change things. So for example, here you can then pass a zoom. You can, for example, choose, let's say, a smaller zoom. You can also change your theta, let's say, to -5. And you can also change your phi. So you can go, let's say, for 90 degrees. So this you should run only in the case you're not happy with your scene and you want to modify it. I'm happy with the scene, how it looks like. So I'm going to go ahead and render the image in 3D format. So I'm going to go here and call, again, ray shader. And there is a function called render high quality, which allows you to export your image in the image format. So the file name is going to be, for example, let's say population2.png. And then one thing that I want to see is preview. I want to see the progress of this rendering, but I do not want to move the scene as it renders. So I'm going to turn off the interactive mode here by specifying interactive equals false. Of course, we're going to have the lights in the scene, so light equals true. And then regarding light, you can specify at least 3 things here. One of them is, of course, light direction. This is something that we also specify in the scene. So this is the source of your light. So 225 degrees means the light is coming from the southwest source, which means that a shadow, if there is a shadow, is going to appear in the northeast. So that's one thing. The second thing that you can add here is a light intensity. A light intensity is something that starts at 500 value, which is again also not intuitive until you see how it looks on your rendered object. But I'm going to go ahead and increase the light, and I'm going to set here 1250. Of course, you can play here with each of these values and see what works for you. The final one is the light altitude. So this is basically the angle under which you are the light is cast, and the higher this value is, going to 90 degrees, means that there is going to be more light on your scene and also less shadow. So if you are applying here the light with a 90% angle, you are directly basically casting the light on your scene. So I'm going to go here for 90 because I completely want to eliminate those shadows and just have a plain look of those spikes. One of the last things that you want to specify is, of course, the width and the height of your image. Here, I'm just going to go and stick with that width and height. They are very small, so I'm not happy about that. This one is 400 and something pixels, so I'm just going to go ahead and increase this 10 times, so I get a more crisper map. And as we said before, you want to multiply, divide, or whatever with the same value, also the height, so that you make sure that there are no distortions on the map. So once you actually run this, the process will start. It should take a few minutes, not more, especially if the country is small as Netherlands. And once you do that, if everything goes well, you should be able to see a 3D map of population density of Netherlands. This looks something like this. One cool thing that we can add to our ggplot and our population density maps is the background layer, where we actually can put either terrain or streets or whatever that can help us pin down that population density that we are mapping. So we're going to go ahead and use ggmap for that and get some of the OpenStreetMap layers for these purposes. So the first thing that we need to do is we need to define the directory, the main working directory here, and we're going to call it here main dir. Next thing is we need to get the country boundaries. So for that purpose, we can use gisco r, and from gisco r, we can use gisco get countries. So once we do that, we can define the country that we need using the ISO2 code. So for the Netherlands, that would be NL. And then we can also choose the resolution. And the crispest one is resolution 1. We're going to go for the next one, which is 3. So once you get this, this is going to be in the SF format. This is going to be 4326 datum of the WGS84 coordinates reference system. We can go ahead and actually create the bounding box for this that we can then pass to ggmap. So let's create country bbox object, which is going to call as a package and especially stbbox function from this package, and we can just pass here this country sf. All right, so once we actually run all of this, what you can get once simply inspecting this country bbox is simply the coordinates for the bounding box, so the minimum and maximum longitude and latitude coordinates. So next thing, what we're going to do is pass these coordinates to a list of things, and then use that list to pass to ggmap and get that background layer. So we're going to create country coords. This is going to be a list. So in this list, we're going to have several things. We're going to have 4 actually members of the list, as we previously saw, so the minimum and maximum longitude values. Now, the way to get what you need from that list is this way. So first of all, you define here country box, then you use this double brackets, and then you name what you want to get. So you want to get the xmin from that one, and you want to get 3 more. So it should be in this order. So ymin, and then xmax, and the final one is the ymax. So this way we have actually all 4 coordinates that we need. And once you define this, the time is ripe to pass this to a ggmap and to get that background layer for the Netherlands. So finally, we're going to create here an object called country layer. Country layer is going to call ggmap, and we're going to get one from stamen map. So we're going to use function get stamen map. So we're going to pass here country coords, and then you can provide a zoom. I here opted for a zoom of 8. Netherlands is territorial, a small country, so the higher the zoom, the crisper it is. But in some countries that are very big, you might want to go for a lower. Anyways, ggmap will warn you if it needs to download a lot of tiles and then put them together. So map types, there are a lot of map types, but one of them that I want to use here is terrain. And terrain is usually in, you get it in a color. So usually there is some kind of a green background, but I would really like it to be black and white. So for that purpose, I'm going to say here that I want color black and white. And you also need to add one more argument, which is force. So you need to force this change because otherwise it's going to just return you the green one. If you follow all those steps, you can then simply check if you really got this background layer as you wanted. So you can just type here ggmap and then the name of this layer object, which is country layer. And once you run this, you should be able to see the country layer for the Netherlands, which looks something like this. Our third method is the contour map, which allows you to plot lines around different population densities and of course in different colors. So if you're personal lines, this is the map to go to create population density map. So here we're gonna go ahead and add that background layer that we just created because it's gonna give us a bit more context where we stand with regards to contours. So to do that, you can simply call here ggmap and again ggmap function, and then simply here pass your country layer. So this is the first layer, and then we can go ahead and add another layer, which are going to be the contours. So that's going to be geom contour arguments. So the data here is it's that data frame that we created. And again, we need to pass in the main aesthetics 3 or actually even 4 things. So the first thing is the coordinates x, which equals x. The second one is the coordinate y, which equals y. The third one is what we used fill before, and here it's called z. But again, we're going to use pop column for that. And there is a fourth one, which is the color. And for the color here, what you actually need is you need to define a generic function, which is called after stat level, which is going to create different colors for your curves based on this statistical estimation from this function. So this is not something that you can control in this case. But what you can control is the line width of your curves, which can go from, let's say, 0 to 1. We're going to go for a bit thinner ones, let's say 0.2. And then very importantly here at the end, you want to not inherit the aesthetics from that ggmap, because if you do inherit that aesthetics, then we won't see any contours. So you want to put here inherit.aes equals false. Once we do these things, we can go ahead and work on the customization of our plots, which includes the colors. So again, we can use scale fill gradients, and then we can go ahead and define the names here. So the title name is, as we said, people per 1, and then square kilometer, which is something like this. And then we can also define the colors here, which is simply pale. We can also customize the legend using the guides argument, and because our main aesthetics is color of those contour lines, we can define color and use the color bar. So guide color bar. This is used again for the continuous scale. Here, once more, we can define several things. So one of them is, for example, that we want a horizontal legend. We can also choose the bar width. So this is the thickness, let's say 0.25, and also bar height, which can be, for example, so actually it's in reverse. Bar height is the thickness, so 0.25, and this one is actually 12 bar width. So because we have a background layer here, we do also need to specify how the chords are going to be handled, and ggmap layers work best with chord Cartesian, so the Cartesian coordinates, and we're just going to pass this here to ggplot2 using chord Cartesian, and wrap this up with theme for the win. And then once you run this code and print this map, you should be able to see the contour population density map of Netherlands that looks like this. Again, we have in the top corner, we have legend. Now, finally, we have also the background layer, which helps us actually put things into context. You will also see those contour lines. Some are smaller pockets, so they apply to a smaller area. That's a specific population density. Other contour lines are actually bigger and comprise a larger actually pockets with a certain population density. But again, here we a lot depend on, of course, the color to show us what is the population density and also what is the area that that population density encompasses. And that's all for today, folks. In today's tutorial, you learned how to use a WorldPop data on population density to create 3 types of population density map. In specific, we use the use case of the Netherlands, but as I showed you, you can do this for any country in the world, and I'm really looking forward to your own use cases and how you use this tutorial to create population density maps for your country of interest. If you're interested in replicating today's analysis, I prepared a GitHub repo in the description below, so do check it out and feel free, of course, to clone it, reuse it, modify it as you see fit. If you have any questions, comments, or just general feedback, feel free to reach out to me here on YouTube, but also on Instagram and X. Also, if you're new to R and you seek to expand your knowledge of data visualization and geospatial analysis with R, I prepared a cool few tutorials for you, so do check them out. See you next time.